Okay, this is a focus lesson on chapter 6.5. Keep in mind that a focus lesson is supposed to be one where you simply watch, so you shouldn't be taking notes yet on this. You will be given a guided instruction after this is over to work on together, but for right now, just kind of listen through. What I'm going to be doing on this focus lesson is approaching it from a student's perspective, asking myself a lot of questions. Again, just kind of think through it with me. And if after I finish, for example, problem 1 or a part of problem 1, and you don't understand what happened, just raise your hand, or bring your computer up, or bring your computer up, or raise your hand and ask me about whatever it is that you did not understand about what I did. Problem 1 asks about the ordered pair being a solution of y is greater than x minus 3. And from what I remember, y and x being two variables, I also see an ordered pair. I remember that in the ordered pair, the first one is usually x, the second one is usually y. And from what I've learned in math, whenever I have an equation like this, I should be plugging numbers in. So in this case, I'm going to turn this y into a 2. I'm going to leave this as greater than. This turns into a 1 because that's x minus 3. Again, and from what I remember from this, I'm supposed to simplify, and 1 minus 3 is negative 2. And in the end, the question is 2 bigger than negative 2? In other words, would the alligator choose 2 over negative 2? Because that is true, I believe the answer to that question is yes. So simply take the point, plugging it in, and seeing what's going on. I think that that's all I'm really being asked to do. Again, over here, you have an ordered pair negative 3, negative 7. And again, I remember that in the ordered pair, this is always x, this is always y. And so when I go to plug it into this equation, the y should be turning into negative 7. Keep the sign the way it is, greater than. X should be turning into a negative 3 minus 3. Here you have negative 7 is greater than negative 6. And I'm not really sure because these are crazy. So one of the ways I know to make sure is to kind of think of a number line. In a number line, you have the positive numbers going this way. You notice that 3 is bigger than 2, 2 is bigger than 1, so the bigger number is on that side. But if I go to 6 and 7, it'll be negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, and negative 7. And I notice that negative 6 is on the bigger side. In other words, you'd rather 06 than 07. This is false because it should be going towards the 6, so the answer to that, because it is false, is no. And so again, the first one is a solution because it is true. The second one is not a solution because when I plug it in, it ends up being false. Again, if you have questions on that, feel free to raise your hand, ask me questions on it, and I'll try to get you straightened out on that. Looking at problem number 2, it's going to be asking us to graph a little bit. And so in order to graph, we have to remember our fundamentals. We had two different types of graphs that we worked with. We had the slope-intercept formula, and we had the standard form. From what I remember in our lessons, slope-intercept was when y was all by itself, and it was the form y equals mx plus b. And I noticed that that's a similar form. The only difference is that there is a greater than instead of an equal sign. And so let's see what we can do with this first, assuming that that was an equal sign, and then see what goes on after that. So the first thing we're going to do is graph this. By the way, in case you're wondering what I'm doing, I'm making a straight edge. In case you're wondering how to graph this, keep in mind, and from what I remember, this x is the same as being y is greater than 1x minus 2. I also remember that I'm supposed to look at this number first in slope-intercept form, and that this is telling me to go 2 down. Another thing I remember from class is that whenever there's no numbers, I have to label and tell the teacher that I'm counting by ones, for example. And since I am going 2 down, I'm going to go 2 down from here, and that is my y-intercept because that was b. In this case, my slope is 1, and what that means is 1 is the same as 1 over 1, which means up 1, right 1. And so from there I go up 1, right 1, and I'm going to draw a line. But here's the funny thing about this. From what I remember about the greater than symbol, for example, 6 is not greater than 6 because those two are the same, so you really can't put the same exact thing. And so I don't think my line should represent the same as it would if that was an equal sign, because it's not really equal. So I think the next thing I'm going to do, because these two sides cannot equal each other, is I'm going to use a dotted line. You will learn at some point that the dotted line is what you're supposed to use whenever it's just greater than or less than. But keep in mind again, whenever this dotted line is here, it means that this side cannot actually equal that side. They can just come really, really close together, which means that my solution can come really close to this dotted line, but it cannot touch that actual solution area. So that's what this line here means. It should be dotted. But another thing I have to remember is whenever it is less than, greater than, that there has to be more than one answer. For example, I remember when it was x is greater than 3, that I would put a 3 and then I would shade, open circle of course, because remember it can't equal 3, and then I would shade to one side. Well, I think I have to do a similar thing here. And so here's what I'm going to do. Because 0, 0 is an easy point to check, I'm going to check to see if 0, 0 is actually true. Notice that this is the origin. This is where x equals 0 and y equals 0. So what I'm going to do to test it is I'm going to put a 0 in for y, I'm going to put a 0 in for x, and I'm going to leave everything else the same. And then I'm going to see if 0, 0 is a solution. 0 is greater than -2. That is actually true. And so from what I've learned in math, if this line represents the actual graph of the equation, what it does is it separates all the true equations or true solutions from the false solutions. And if I tested 0, 0 and 0, 0 was true, it means that everything on this upper side is going to be true, and it also means that everything on the bottom side is going to be false, because this line separates it. So if I'm shading where the true solutions are, if 0, 0 gave me a true solution, then what I'm going to do is shade towards it. Again, because 0, 0 is true, that means everything on this side is true, and so you stay over there. If I would have got 0, 0 is false, it would mean that everything over here is false, and I would have jumped down here and shaded that side. But again, this isn't an equal sign like what we've been used to. The greater than symbol means that I actually have to shade area to make sure that everything is right the way it's supposed to be. So again, if there are questions on that I can help you with, raise your hand, bring the computer over. It's probably better if you bring the computer over and ask your questions, or just come over to me and ask questions so that I can help you get on track. They want the graph of each inequality on problem 3, and from what I remember on problem 3, these are the tricky questions where it's just a x or it's just a y. And so the first thing I'm going to do is I am going to recognize that I am again going to count by 1. I go to where x is -1. This is my x-axis. X is -1 here, and from what I remember, the way that I graph this is if this is x, then I go through the line that goes through x. I also remember that this means that these two cannot equal each other, so I use a dotted or dashed line on that. And so because this is already straight, I'm just going to go ahead and use a dashed line or dotted line to do that there. And again, this line that I just drew, because that is the graph, separates everything that's true from everything that's false. Again, that line goes all the way down, it goes all the way up, and each of these sides are now divided into everything true from everything that's false. So what I'm going to do again, because the origin is available, is I'm going to plug in x equals 0, y equals 0, which of course means that all I have to do is put in 0 for x and see if it's bigger than -1. Because 0 is bigger than -1, that is again true. And because 0, 0 is true, it means that everything with 0, 0, all these points on this side, should all be true, which means that I will shade this way. And so again, that's what you're looking for. The line itself has to be there, and then you simply shade one side. And because 0, 0 is true, because 0 is bigger than -1, you actually stay over there. Again, if 0, 0 was false, I would have jumped over the line and shaded the other side. Looking at graph B, y is greater than or equal to 2. First off, again, let's mark that we're counting by ones, and let's go to where y is 2, which is up here because that is my y-axis. Again, from what I've learned about these single letter graphs is that whenever you're on y, you simply follow the line that goes through it. Notice that this is equal to 2, so these two things can equal each other, and because of that line being under it, you want a regular line. The way I remember it is if there's a line underneath the symbol, then I use a regular line. If there's not a line underneath the symbol, then I use a dashed line. That's just something that I use to kind of think about it, but whatever works for you will work for you. Let's again test 0, 0 because it's available right now. And so x is 0, y is 0. The only thing we have here is y. Let's plug in 0 and see if this is true. Is 0 bigger than or equal to 2? No. And so that's false. And because 0, 0 is false, that means that everything on this side is false, which means we don't want this side. We want to go to the other side and shade above the line. Again, if 0, 0 is false, that means that everything on this side is false, so we must go on to the other side of 0, 0 to find where we shade. Okay? So again, if there are any questions on that, bring it over, ask about it, figure it out. We've got a different way of learning this time, and it's more along the lines of what the district wants us to be doing. So before you move on to problem 4, again, make sure you understand everything else in front of you, because these things just kind of keep moving forward. Problem 4 talks about an interior decorator going to remodel a kitchen. The wall above the stove and counter is going to be redone as shown. The owners can spend $420 or less, write a linear inequality, and graph the solutions, and they want 3 possible prices for the wallpaper and tiles. Based off of what this shows here, it shows that the tiled area is 3 feet by 4 feet, which means that this is 12 feet squared. So what they're telling me here is that this takes up 12 square feet of space. They're telling me that the papered area on this is 3 feet by 8 feet, which is 24 square feet of space. So you know you're going to have to pay for 12 square feet of stuff here, and you're going to have to pay for 24 square feet of stuff here. We don't know the prices of what's going on, so what we're going to do is let X represent price of tiled area, and we're going to let Y equal the price of papered area. Because you're not going to have the same price, we need 2 variables going on there. And so what has to happen here is that you're talking about making an inequality. First off, your inequality is that 12 times the X, because you're going to have 12 square feet times the price of X, plus, because you're going to also add in the papered area, 24 square feet times Y, because there's 24 square feet times whatever the price of a material that we have to buy. Again, if we have 12 square feet of material at X per square foot, 24 square feet of material at Y per square foot, it says can spend $420 or less, which means that this has to be less than or equal to $420, because again, it cannot pass $420, otherwise we're spending too much money, and it can actually equal $420 because it says $420 or less. So you're looking at this price, 12 times X plus 24 times Y less than or equal to $420, and it wants us to actually graph this and find some solutions. I'm not going to worry so much about finding the solutions, because I think we did that in our bell ringer today. All you have to do is just find some prices and pick some and go from there. But in terms of graphing, I do want to go to that. So I want to look at this part here. Again, I'm going to go ahead and copy the formula. 12x, 24y, 420 should be less than or equal to 420. And again, what we learned here is that we pretty much just ignore that, treat it like an equal sign, but we also recognize that this is not slope-intercept form. Because it's not slope-intercept form, it means that I am going to look for x-intercept and y-intercept. Whenever it's a y equals formula, I can do it the way where I find the slope, I find the y-intercept, I plot them. But in this case, it's in standard form, so I need my intercepts. From what I remember about x-intercepts, it means that we ignore y. So treating this like an equal sign, I will put 12x equals 420, and I will divide by 12 to find out that it is 35. The x-intercept is 35. Same thing, I will do 24y. For my y-intercept, it means ignore x. And so I will divide 420 by 24, and I get 17.5. So using that, I'm going to call the x, since x is my tiled area, this will represent my tiled price, because remember I have to kind of label this, otherwise we don't know what's going on. This would represent my paper price. And putting all that together, I now have to kind of see what's going on. Well, in order to get my tiled price, the x-intercept is 35. 5, 10, 15, 20, 25, 30, 35. I think 5s work here, so counting by 5s. Because if you recall, we have to label these, otherwise the person doesn't know what's going on. We also know that we have to label them the same distance. We can't count by 1s and 2s all in the same part here. So the x-intercept is 35, which is here. The y-intercept is 17.5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Pretty close, but I think we have to count by 2s here. And so counting by 2s, that's 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. 17.5 will be in between 16 and 18, and the trick that we learned here is if 16 and 18 has 17 in the middle, if this is 17, that's 18, 17.5 would be right there in between those two. And that was something that we learned, I think, doing our statistics thing or scatter plots. And so taking this, now you want to go ahead and connect these two. Because there is a line under it, it means that we put a line under this also. And that is where we are. Alright. So outside of that, that is our graph. It's not going to go below because the paper price is not going to go less than 0. It's not going to go beyond that part because the tile price is not going to go less than 0. So you pretty much keep the graph in that area there. Alright. And the last problem that we're looking at today before you do your guided instruction is problem 5. It wants to know which inequality represents the graph shown. So this is pretty much asking me to take the picture and create an equation for it. So we need to use our common sense here and look back and say, I know that the y-intercept should be 2. I'm sorry, it should be 1 because this is 2. That's 1. So my y-intercept should be 1, so I see that in all these things here. So plus 1, plus 1, plus 1, plus 1 works. The other part I know about the line is that I can find its slope. And there is a second good point, and in terms of rise over run, I rise 2, run 1, which means my slope should be 2. And so I'm looking for a slope of 2, which means that B cannot be it because that has a slope of 1. That's out. This one here, 2x plus 1, 2x plus 1, 2x plus 1. So now I just have to kind of look and recognize that, yes, I have 3 options, but one of these options must be true. And the first thing I notice is this is a solid line. That would give me a solid line, that would give me a solid line, but from what we learned today, that would be dotted, so it cannot be D. And the last thing I need to do is recognize that 0, 0, because it's shaded here, is true. And so let's go over here and see which one 0, 0 works for. So if I put a 0 here and a 0 here, it'll be 0 is less than or equal to 2 times 0, which is 0 plus 1. 0 is less than or equal to 1, which is actually true. So I think that's right, but let's just check real fast. 0 greater than or equal to 2 times 0, which is 0 plus 1. Notice this says 0 is greater than 1, which is false. And again, because 0, 0 is shaded here, that means it's true. The answer has to be A. Alright. So now that you've gone through all that, this is where you will get together, get your own sheet of paper out, and work on this. So you have four questions on guided instruction. You might need to pause the video to work on 1 through 3 or whatever it might be. But other than that, just make sure you're doing it. Again, do your work on a separate sheet of paper. You should work together. You can also rewind the video for a review because these are questions just like the focus questions I gave you. And it is actually due today, so put your own name on your own paper. I'll grade it, and then you'll get your participation grade or your class work grade off of that. So don't give me a sheet with a whole bunch of wrong answers because that'll actually hurt you. So you want to work to get this right. You can use me, you can use each other, but I want you to use each other. I want you to start using your groups, using the people around you to start kind of discussing what's going on. So the 3 questions here, and then the 4th question being right here. Alright, and they just want the equation of that graph. So again, 4 questions for your guided instruction. Get those things done and hand those in. I can't zoom out any further because I don't have it like that, but again, just go ahead and work on those. After you finish your guided instruction, hand it in to me, and if you have time, there actually is a second video that has all the solutions to this, and you might want to watch it so you can stay up to speed. Other than that, as I said, pause the video as you need to, and rewind it as you need to for notes. But other than that, good luck today. And again, make sure you get something out of it, because we do move forward tomorrow.